So, good morning everyone. So, welcome to my YouTube channel Maths Saptaram. So, today we are going to see how to calculate limits by polar form. Okay, so limits in polar form. Okay, limits in polar form. Okay, so what is polar form? Okay, so suppose we have this is x-axis, x dash, y, y dash. Okay, so if we have any point xy here. So to reach this point, to reach xy point, we have to travel x distance on x-axis and y distance on y-axis. Where these two points will cut down, it will be xy. Okay. The angle made by this line with x-axis is theta, and this is radial distance. This is non-negative distance. So x will be equal to x upon. Okay, so this is y distance. So x square plus y square is equal to r. Okay, or you can see from here. So x upon r is cos theta. So this implies x is equal to r cos theta. Okay, y upon r is equal to sine theta. So is equal y is equal to r sine theta. Okay. So x square plus y square is equal to r cos theta square plus r sin theta square. Okay, so this is r square cos square theta plus sin square theta. So this is 1. So this implies x square plus y square is equal to r square. Okay, so y upon x is what? R sin theta, R cos theta. So R is cancelled out, that is tan theta. So this implies theta is equal to tan inverse y and x. And from here, what is R? R is under root x square plus y. Okay. So what we mean? Given xy non-zero point, then xy can be mapped to x can be mapped to r cos theta, r sin theta, we have r is greater than 0 and theta lies in between 0 and profile. So this representation is unique. It means xy going to r cos theta, r sin theta, where r greater than 0 and theta lies 0 to 2 pi. This is a function. This is a function. 0 point do not has polar form because we cannot define theta. We cannot define theta. Okay. Not xy is equal to 0, 0 does not have polar representation, polar form because theta cannot be unique for 0, 0. Okay. Because if we have 0, 0 point, this is just a point. What theta we will take? It is not defined. Okay. It is not defined. So now we are going to give definition of the now note the polar coordinates of xy belonging to r square, that is not 0, 0, are given by are given with respect to origin. So polar coordinate of xy point are given with respect to origin. How it is given? X is equal to r cos theta and y is equal to r sin theta. Okay. Okay. Now, now the polar coordinates Now the polar coordinates is x, y with respect to x naught, y naught are given by x is equal to x naught plus r cos theta and y is equal to y naught plus r sin theta. Okay, so r is greater than 0 and theta varies from 0 to theta varies from 0 to 2 pi. Okay, so now we are going to define the limits in polar form. Limit definition in polar form. Okay, that f d to r be a function. D is subset of R2, okay, and X naught, Y naught belongs to R2. We say that the limit of fxy at x naught, y naught exists and it is L if given epsilon greater than 0, there exists delta greater than 0 such that f x naught plus r cos theta, y naught plus r sin theta minus f x naught minus L minus L less than epsilon for all x y belongs to D with for all R with R less than delta. Okay, R less than delta. Okay, and any theta with so let's see how we will apply this. So example 1, thus limit xy tending to 0 0 xy exists. Solution. So we guess that limit will be 0. L will be 0. Okay. So fxy here is xy. Xy minus fxy minus L xy minus 0, that is xy. So put x is equal to r cos theta and r sin theta. So we got r square cos theta into sin theta. But each one is less than, so r square cos theta into sin theta. So each one is less than 1. Okay. So we have because cos theta less than 1 and so this is r square. We want to make it less than epsilon. So what delta we choose? We should choose delta is equal to under root epsilon. That is greater than 0. Then then has r cos theta r sin theta minus L is less than epsilon. L is here 0 for all r with in this range and theta with, okay. So what is the meaning of this? This means limit xy tending to 0 0 xy is equal to 0. Okay. So here I should write any theta with this range. Okay. So example 2. Thus limit xy tending to 0 0 x square plus y square mod x plus mod y exists. Solution. So limit will be 0 actually. We guess limit will be 0. So fxy here is x square plus y square mod x plus mod y and L is equal to 0. We will check L is equal to 0. Okay. So f r cos theta r sin theta minus L, that is nothing but r square cos square theta r square sin square theta r cos theta r sin theta minus 0. So r square cos theta plus sin theta. So r is cancelled out. So r cos theta plus sin theta. Okay, we have this one. Okay. Since cos theta plus sin theta is always greater than equal to 1. Always greater than equal to 1. Then because f r cos theta r sin theta minus 0 is less than equal to r upon cos theta plus sin theta. Because this is greater than equal to 1, so this will become like this. So this is r. I want to make it less than epsilon. What delta I should choose? Delta is equal to epsilon. Then f r cos theta r sin theta minus 0 less than epsilon for all r with 0 upon delta and any theta with, so this implies limit xy tending to 0 0 x square plus y square and x plus mod y is equal to 0. Okay, so it is done. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next week.